Hi, hello everyone. Good afternoon, मेरा प्यारा बच्चा लोग सब कैसे हैं? How are you all doing? I know that you all are here after the weekend. I know that you will be having so many stories. ठीक है? And I know that you might have learned a lot. And in today's session, we are going to be learning another topic of thermal properties of matter. And how are we going to learn this, मेरे बच्चा लोग? By doing tons and tons, not tons and tons, let's say almost by doing 30 questions from the chapter of thermal properties of matter in this particular class, and we'll make this chapter as concrete and as great as possible. I hope you all are ready for that. Before that, this is Ameer, your physics educator at Unacademy, and those who love me more, they simply call me Bhaiya. And even before we start with the session, I want to ask you, bachcha log, how are you all doing? Kaise? How are you all doing, everyone here in this classroom? Hi Nandini, Ikroob. That's a really unique and a great name, I suppose. Good to know that. Sahil. Okay, so Sahil is already promoting me there. Thank you so much, Sahil. Komal, hi, hello. Yeah, we're gonna start as soon as possible. That start is for WhatsApp. Okay, Mansi, hi, namaste. Agansha, thanks for teaching. Obviously, I'm so thankful and I'm so happy to teach every one of you, मेरे बच्चा लोग. Shreya, Rukshar, Sartag, Mansi, Daksh, Prabhakar, Saurabh, Akansha, Pipin. A big hi to every one of you and good afternoon. Now, as I have told you, we'll be doing thermal properties of matter in today's classes. Okay? And we have so many beautiful questions waiting for us. Before that, let me give you some introduction about our Unacademy platform. Dekh le. Now, if you don't want to miss any of the live classes from any of your favorite teachers, you can be a part of the Telegram channel. The link is given here and also in the description. Fine. Moving on, Bugs Bounty. It's an amazing program to help you grab as many prizes as possible. You just have to go to the description. There you'll find a form. Fill the form if you're finding any inappropriate content in the videos uploaded by Unacademy. If it is valid है ना बच्चा लोग, बहुत सारा prizes मिल जाएगा आप सब लोगों को. ठीक है? Moving on. We have two kinds of subscription, plus subscription and iconic subscription. In plus subscription, we will be having live classes, or you will be having access to all the live classes, and even if you miss any live classes, you can have access to the recorded classes, structured courses, then a weekly test will be possible. Everything will be there to make you all perfect for that. Now, we have iconic subscription where you'll get all the features of this plus subscription plus some extra features such as a personal mentor. A person will be assigned to you. He'll be looking after all your academic activities such as okay, what all studies to be done in a particular day. Okay, how much portion you have to complete, how much should be your rate of study so that you can complete before the examination start and you can have a proper revision. For every planning, this person will be there. Then you will be given separate live doubt solving classes will be there. Okay, everything will be there, and you will enjoy a lot this process of learning, and you can see the progress in yourself. Okay, and that will be so awesome, and you will start loving it. Now, if you go for 12 months, it should cost you 1,250 per month for plus subscription, and for iconic subscription for 12 months, it should cost you 2,333 per month. Now, from this price, if those who need 10% of discount, what do you all need to do? Use this code hamara, which is AMB10. Okay? Use this code, get 10% of discount from the already above mentioned prices and enjoy your life, मेरा बच्चा लोग. ठीक है? Now, देख ले, only for the first 500 subscribers, as exams are coming and Academy made a special offer for you. Right? Because we love you all, isn't it? That's why if you go for 3 months plus subscription, extra 1 month is given free. So don't miss your chance. Okay, this is only possible for the first 500 subscribers. Make sure that you are one among those 500 subscribers. So just go for it and claim your offers. Now, if you have any doubts related to any of the Unacademy subscription policies, plans, courses, or anything, you can get in touch with the counselor. The counselor's number is given here 24/7. You can call at any point you want. Now, open house sessions keep on happening. You can get in touch with your teacher. You can talk to them, and it'll be awesome. Right? Yes or no? Yes, welcome. Now it's simply time for us to start with our session. Are you all ready for that? Are you all ready for that? First question is here and many questions are waiting for us. Now, if you all are ready there, and if you all are ready to shout out, yes sir, we are super duper ready. Okay, we're gonna start. Yes, Tanuja, Mansi, Jia, Sneha, Rukshar, Mariam. Okay, already given the answer. I'm not telling false is the answer. Okay. Okay, awesome, awesome, awesome. Cool, cool, cool. ठीक है. Start reading the question. The temperature at which Fahrenheit and Kelvin scales gives the same reading as 574. मतलब, if you are measuring the temperature of a body by using Kelvin scale and Fahrenheit scale, the statement says both of them are giving a value of 574. Is it possible or not? Okay, is this a true statement or is it a false statement? Or at a temperature of 574, can this Kelvin scale and Fahrenheit scale can have the same value or not? How can we do this? How can we do this? We should be knowing that simple conversion rate from the Fahrenheit scale to Kelvin scale or the vice versa thing. If you know that particular formula, right, we can make the connections there and simplify, you will get the answer. Then you can comment whether it is true or false. Let me see, कौन कौन already दे दिया है? Okay, Ruksha, Shweta, Rani. Okay, everyone is going for false. अरे बाप रे, ऐसे कैसे? ऐसे कैसे? Okay, now I'll solve it for you. देख ले. I'll explain the concept also before doing this problem. We have a body. Red is not a good color, sir. Change kar le ab color. Okay. Now we have a body. Okay, this is a hot body. Now I'm measuring the temperature of this body by using Kelvin scale, and I got the value as K for this. Now I'm measuring the temperature of this particular body by using a Fahrenheit scale. Okay. Now tell me, what is the relationship between this Kelvin scale and Fahrenheit scale? How can we know the relationship? Those who attended my classes, I have told a general relationship that can exist between different scales of temperature. What is it? I'll tell you. That is, temperature of a body in one scale, here let's say it's in Kelvin scale, K, minus, then freezing point of water in that same scale, the whole divided by boiling point of water in that same scale minus freezing point of water in that same scale will be equal to the temperature of the same body in another scale. Here we are using Fahrenheit minus freezing point of water in that new scale divided by boiling point of water minus freezing point of water in the other scale. This is the simple relationship which connects temperature of a body in one scale to temperature of a body in another scale. If you know this relationship, you can make the conversion from one scale to another, whatever may be the condition possible. Okay? So don't forget it. So if you are using any scale of temperature, you can put, instead of let's say Kelvin and Fahrenheit, we are having scales of X and Y. So here we can put the temperature of a body in that X scale. Here we can put the temperature of that body in Y scale. I see. Okay, now let us start substitution. K minus. What is the freezing point of water in Kelvin scale? That is 273 Kelvin. Divided by boiling point, it's 373 minus freezing point again 273 is equal to F minus what is the freezing point in Fahrenheit? 32 divided by boiling point, it's 212 minus freezing point again 32. Any doubt in this? According to the formula, we have just substituted the values. I hope you all know this, right? So those who don't know, in Fahrenheit scale, the freezing point of water is 32 degree Fahrenheit and the boiling point is 212. Okay, now let's solve this. That's all what is remaining. As you can see here, it says the temperature at which Fahrenheit and Kelvin are equal. Matlab, the temperature at which the Kelvin scale and Fahrenheit are equal to each other. Let put it as some X value. Okay, so substituting it as X minus 273. देख ले 373 minus 273 is 100 is equal to क्या मेरा बच्चा लोग F is equal to X here according to the question minus 32 divided by 180. अरे ये तो सिंपल है, right? I'm leaving the remaining part to you. Matlab simplification. Take like what you can do. 0, 0. 2 goes 5 times. 2 goes 9 times. Cross multiply. You will get x value as this. 574. Which means whatever is the statement given here, that's true only. Okay, whatever is the statement given here, है ना बच्चा लोग, वो तो सही है. True, isn't it? Yes, Mithilesh, yeah, I hope you all understood your mistake and I hope you all have marked this formula. So if anyone is new to my classes, okay, you got a bonus point or a bonus formula. Bonus formula. Kyun bonus formula? Because this is a formula which can help you to convert the temperature from one scale to another in any fashion. Okay. 0.25 ज़्यादा है रे, approximation है रजवीर, ठीक है? Oh, Mithilesh, you already said true. Very good, very good. Awesome. So, बच्चा लोग अगला question के लिए ready? Steady? Okay, let's go. Here we go for the next one. देखिए, not a big deal at all. Okay, not a big deal at all. Simple, नन्नू मुन्नू question है. So yes. Go for it, every one of you. I'll give you 30 seconds of time. In the meanwhile, you can do it and give the answers. Still, if you are not able to do it, I'll start explanation after 30 seconds. Okay? Now, during that 30 seconds and during the time whenever I'm solving the problem, you can still put the answers here in the chat box. Okay? I'll be looking after me solving the question who have already given the correct answers. Fine. Has anyone given me the answers already? Mohit, Status, Meru. Okay, I'm just reading out the correct answers. Okay, so I can see so many options here, right? Jia says C, Nandari says A, Ayan says C, Mithilesh says C, Anera says A. So class 12, tomorrow we'll be doing ourselves, okay? So tomorrow's class is for class 12 wave optics. Okay, moving on. Dekhiye, how will we do this? A general rule of thumb used by pilot is for, forget it. Okay, alto falto kuch bol diya. We shouldn't be knowing about all those stuffs, or we don't have to know about all those stuffs for doing that. Okay, it says for every 1000 feet the temperature falls by 3.5 Fahrenheit. What does it say? We'll write it. For every 1000 feet temperature drops by 3.5. Okay, so if the temperature at the sea level is 78 Fahrenheit, what would we expect the temperature to be at 10,000 feet? Okay, at a 10,000 feet, what will be its temperature? We are asked to find the temperature not in Fahrenheit, finally in Celsius scale. Matlab, after finding out, the Fahrenheit has to be converted into Celsius also. ठीक है, तो थोड़ा काम है. We'll start. For 1000 feet, temperature drops by 3.5. So how will we find out the temperature dropped in 10,000 feet? Simple, we'll find out the number of thousands in 10,000, right? 10,000 by 1000 will give you number of thousands. Why we are finding number of thousands? Because for every 1000 feet, there will be a drop of 3.5, right? So what will be the number here? 10,000 by 1000, it's 10. So 10,000s are there. For every 1000, 3.5. So if there are 10 times 1000, how much will be the temperature drop? Total temperature drop will be equal to 10 times 3.5. How much is it? 35. So the temperature will drop by 35. So if the sea level was having 78 Fahrenheit, and if we are moving up by 10,000 feet above the sea level, what will be the temperature at that particular point, which is 10,000 feet above sea level? How much will it be? From the temperature of sea level, that is 78, subtract the temperature drop. How much is the decrease in temperature? 35. So we'll write temperature at 10,000 feet is equal to, from 78, subtract the decrease in temperature. How much is it? 35. So how much will we get? This will be 43 Fahrenheit. Okay, which means at a height of 10,000 feet, the temperature is found to be 43 Fahrenheit. Very simple, but we don't want this 43. Kyun? अरे हमको चाहिए in degrees Celsius, right? So let's make the conversion. कैसे? We all know the simple conversion between degrees Celsius to Fahrenheit. Formula 5 by 9 F minus 32, isn't it? Now substitute the value of F, that is 43, minus 32 into 5 by 9. We will get the final answer as 6.1, which is option B. Okay. Simple nanu munu concept, isn't it? Yes or a no? Yes or a no? Isn't it? Happy, happy, super happy. Okay, any doubt in this? Any doubt, anyone? Nanu munu question tha, right? Yes, it's option B, right? Do you want me to solve it numerically? Let's solve it. Let's solve it and see. 43 minus 32 is 11, right? So this is equal to 5 by 9 into 11. So this will be 55 divided by 9. So 55, 9, 54, 6 times, right? 9 times 6 are 54. So 6.1 degrees Celsius. Nannu munnu concept. Kitna simple hai? Then I don't know why everyone was going with the option A. Everyone was like, sir, isn't it option A? Isn't it option A? Ulta ho gaya kya? Okay, actually it's 6.1, not 1.6. Anyway, sabko mil gaya. Agla question. A nannu munnu question from which topic? Yes, ideal gas equation. Jaldi chalo mera bachcha log. Yes, I already have started the next question. Waiting for the answers from every one of you. Future astronaut, Hindi तो मुझे पता नहीं. Anyone? Okay, I'll read the question for you. In the meanwhile, you can keep on giving me the answers. Calculate the temperature at which 0.654. I hope you all can see. Yeah. Moles of neon gas occupies 12.3 liters at 1.95 atmosphere. Matlab the temperature. Number of moles is given, volume is given, and atmosphere is given. Who wanna give me the answer as fast as possible? Kisko dena hai? Shraddha is like, sir, D option. D option. Okay. So shall we solve it? Nandini is also going for D option. WhatsApp is going for C option. You can keep on giving me the answers, okay? I'll be solving it here. In the meanwhile, you can keep on giving me the answers. Dekh le. Number of moles is given, as I have told you. Volume is given and pressure is given. So how will we find out the temperature? Simple. We should be simply knowing PV is equal to nRT, which is the ideal gas equation. सबको पता है ये, है ना? ठीक है. Now start rearranging. T value is what we have to find out, right? Okay. So T value will be equal to PV divided by NR. अब क्या बाकी है? कुछ भी नहीं, just substitute कर ले. 1.95 atmosphere. Can I write it as 1.95 itself? नहीं. क्यों? Because the SI unit of pressure is Pascal, so we have to convert from atmosphere to Pascal. Conversion rate क्या है? 1 atmosphere is equal to 1.01 into 10 power 5 Pascal. So 1.95 atmosphere is equal to 1.95 into 1.01 into 10 power 5 Pascal into volume is 12.3 liters. How will you convert to meter cube? By multiplying it with 10 power minus 3. Because Meter cube is the SI unit of volume, not liters. Okay, so multiplying it with 10 power minus 3 by n value is 0.654 into R value is 8.314. And how much we are going to get, mera bachalo? We'll be getting the answer as 447 Kelvin, which is option A. Simple, right? Isn't it? Yes or no? Bol do haan sir. Yes, of course, bilkul. Okay, Jia. Bye-bye. Hi, Naman. Hi. You don't have to spam here. I can see. Naman, kindly don't spam. Okay. So, any doubts, anyone, on doing this particular problem? No, right? Sab badhiya? With full of thumbs up. Okay. So, ready for doing the next one? Are you all ready for doing the next one or what? You're ready? Mithilesh, back in action. Go for it. Next question is right in front of you. Let me see within 30 to 40 seconds how many of you are going to give me the answer. Jaldi se. I'll read the question. Actually, this is also a question which you can solve it by using ideal gas equation itself. If the pressure on an enclosed gas is doubled, okay, and its temperature rises from 27 degrees Celsius to 127, what will happen to its volume? It's a comparison question. Simply, you can easily compare this and get the answer out of it. Let me see who's going to be the first person to give me the answer. I'll start explaining now. Okay, I can see Shraddha with option D, Mithilesh with option C, Rukshar with option C, then D. Okay, so I can see a mix. Everyone is going for the option D. I'll tell you what is the problem for choosing D and what made you all to choose the option D here. Okay, fine. Everyone listen. If the pressure on an enclosed gas is doubled, pressure is being doubled. I'll write it. P2 is equal to 2 times of P1 and the temperature is 27 degrees Celsius. But we know that whenever we solve any equations related to temperature, it has to be in its SI unit, which is Kelvin scale. So that is 27 plus 273, that's equal to 300 Kelvin. Okay, and the temperature becomes 127. So its corresponding in Kelvin scale is 127 plus 273, that is equal to 400 Kelvin. Okay, pressure values, temperature values are given. Question is what happens to the volume. Which formula? As usual, PV is equal to nRT, or V is proportional to T by P. Any issue in this? N and R are considered as constants here. So V directly proportional to T, and when P comes to the right hand side, that will be inversely proportional. Any doubt? No, right? Now what is left? Just start substituting and get the answer. That's it. So V1 by V2 will be equal to, as it is directly proportional to temperature, that will be equal to T1 by T2 into, as it is inversely proportional to pressure, that will be equal to P2 by P1. Any doubt? No, right? Now start substituting. That's all. T1 by T2. What is T1? 300, right? 300, T2 is 400, P2 is equal to 2 times P1 by P1. P1's cancel, right? 2 in 4, 2 times, so this will be 3 by 2. So V1 by V2 is equal to 3 by 2. Taking the ulta, I'll write it here. V2 by V1 is equal to 3 by 2, or V2 or 2 by 3, taking ulta, and V2 equal to 2 by 3 times V1. V2 का value कम हो गया, it has decreased to a value of 2 by 3 V1. And by what value it has decreased? From V1, right? When it came to V2, how much is the decrease? मतलब change in volume कितना है? That is equal to V2 minus V1. V2 is how much? 2 by 3 V1 minus V1. How much is this? Minus V1 by 3. The change in volume, when the volume has changed from V1 value to V2 value, the change in volume is V1 by 3. And the negative sign says that the volume is being decreased. Matlab, the volume is being decreased by a value of 1 by 3, and that's why we have the option B as the answer. And I hope you all understood what is the mistake you all have made. Mistake क्या है मेरा बच्चा लोग? देख ले, you all have went for this option by thinking that the final volume V2 is being asked in terms of V1. No, that's not the question. V2 is 2 by 3rd of V1. Okay, so that's not the question. Question is actually what is the change in volume happening. ठीक है? So understood why it is not the D option, it's the B option. समझ में आ गया ना सबको? अच्छे से, नन्हे से, मुन्ने से. Have a look at it and kindly copy down as soon as possible within some seconds. Okay, next Shraddha is like in super excitement, right, to do as many problems as possible. That's awesome, Shraddha. Yes, Shika, Rukshar. Okay, now I think we can move for the next one then, if everyone is super ready. Next. So we have entered into the topic of thermal expansion. Okay, so start solving it. It's a beautiful question. And if you have any doubts, you can ask me here in the chat box. ठीक है मेरे बच्चे लोग, कोई भी doubt है तो पूछ ले in the chat box. जल्दी. Complete किया everyone? I'll just read the question for everyone of you. देख ले. An iron rod heated from 30 to 80. The final length of the iron is 115 and the coefficient of linear expansion is 3 into 10 power minus 3. Okay. What is the original length and the change in length of the iron? The options are given for the change in length. Okay, options are not given for the original length. Options are given for the change in length of iron. ठीक है? So you can just have a look at all the 4 options, find out which one was your correct one. Anybody gave me the answer already? Meru is like asking, sir, is it A? Shraddha, Rukshar. Okay, so Meru, very good, very good. Many of you are going for the options A here. Let's see. Others can still keep on putting the answers and updating the answers here in the chat box. Okay, I'll explain. Body was having some length of L0 at a temperature of 30 degrees Celsius, right? Now you increase the temperature, so length will become some L value, and now the temperature is increased to some 80 degrees Celsius. Okay, so the final length of the iron, this length is given as 115 utna centimeters. Question is what is L0 and what is the change in length that has happened. ठीक है. So we should write the formula connecting these. किस को याद है? The formula which connect all these things? Simple. The new length L is equal to L0 initial length into 1 plus alpha, the coefficient of, okay, temperature coefficient of linear expansion. Alpha, the coefficient of linear expansion value is given into change in temperature. The new length is given as 115 centimeters. L0 का value we are supposed to find out 1 plus alpha का value, where is it given? 3 into 10 power minus 3. 3 into 10 power minus 3 into change in temperature क्या है? 30 था. 80 हो गया. Change कितना? 80 minus 30, that is 50. ठीक है, नन्नू मुन्नू है। सो ये कितना हो जाएगा, 15 into 3 is 150, 150 into 10 power minus 3 is 0.15. So L naught into 1 plus 0.15 is 1.15. That is 115. So L naught का value 115 by 1.15 कितना, 100 with the unit of centimeter. Simple. देख ले, कोई भी परेशान हो गया तो any problems you are coming across in solving this, अभी बता, tell me now. Simple सा question, नन्नू सा मुन्नू सा question है, right? Is this a final answer? बिल्कुल भी नहीं. This is the initial length L naught. Final question is the change in length, मतलब delta L. How will you find out? Final length minus initial length. How much is final length? Final length कितना दे दिया देख ले, 115 minus initial length कितना है, 100. How much is it? 15 with the unit of centimeters. So A is our correct answers. देख ले, if you know this simple formula for thermal expansion, anybody can do it. किसी को भी जल्दी से नोट डाउन कर ले. In the meanwhile, let me see कौन कौन दे दिया था उत्तर. Meru, Shraddha, all these people who are super active here in this classroom. Good. Rukshar, right? Nasir. Okay, Nasir gave me option C actually. Okay, cool. Doubts any? No doubts. मतलब have you all copied down? किया अच्छे से? Proceed कर सकते हैं ना? Okay, moving. Next one. This is a very good question. Let me tell you that. It's a very good question. अच्छा वाला question. Let me see who all are capable enough for solving this particular problem. Hi Bhuvika, hi. Anyone already giving? Hi Shahid Kapoor sir. मेरा नाम भी बदल गया क्या? Shraddha C. Meru is like going for option C. Okay, many are going for option C there, which is 10.44. But let's see which is our correct answer. ठीक है? देख ले. A 2000 centimeter cube aluminum container filled with water at 0 degrees Celsius. Let's draw this. Then only you'll be able to understand. Okay. So here what do we have? Here we have a container. Okay. Its volume is equal to how much? Volume of the container is equal to 2000. Now you are filling this particular container with some water. Obviously, water take the volume of the container. Matlab, volume of the water is also equal to 2000. Matlab, initially, both of them were having the same volume. Now, it is heated to 90 degrees Celsius. When the temperature is increased, what happens? Container will also increase and the water will also increase its volume. ठीक है? Now, linear expansion of aluminum दे दिया है. Coefficient of volume expansion of water is given. Determine the volume of spilled water. Question is, when the temperature is increased, how much volume of water is getting spilled out? How is this spilling case is happening? Just think of this case. During the increase of temperature, container increases its volume, water increases its volume. If the water is having more increase of volume or after reaching at a temperature of 90 degrees Celsius, if the volume of the water is more compared to the volume of the container, what will happen? Water will be overflowing. Why? Because water, the entire volume of water will not be having space to stay inside the container. Because at 90 degrees Celsius container is small, volume of water is bigger, it will flow out. So question is, how much volume of water is flowing out? How can we find out? From the final volume of water, subtract the volume of the container. Then you will get the volume of water that is overflowing. Sir, thoda aur samjhao. I'll explain. This is the case at 0 degrees Celsius. Now, I'm increasing the temperature to kitna? 90. So let's say this is the new volume of the container, VC dash. Okay. Obviously, along with the increase of container, water will also be increasing its volume. What do you all say? You all agree with me? And water will also be increasing. Water has increased its volume to this much. This is volume of water dash. Now, in this figure, this much volume of water. Can you see this much volume of water? That green colored portion of water that is coming out of the container. So won't this water be flowing out? Yes. So this is water flowing. Okay. Tell me, how can we find out this much volume? From the total volume of water, that is VW dash, okay, subtract the volume of the container. That will give you volume spilled. Check. Any doubt is there or not? No doubt, I suppose, right? Understood the method of finding volume spilled? Now our only task is to find out the volume of the water and container when temperature is increased. We have the formula. What is it? Volume of the water is equal to initial volume of water into 1 plus gamma delta T. What is the initial volume of water? 2000. Into 1 plus gamma is the temperature coefficient of volume expansion, that is 6.3 into 10 power minus 4 into change in temperature. How much is the change? From 0 it becomes 90. Okay, so once you do the math, you'll all approximately get the value of 2113 approximately. Okay? Volume of water. Similarly, the new volume of the container at 90 degrees Celsius, formula same, 1 plus, it is gamma delta T, gamma of the container. लेकिन gamma नहीं दे दिया है, which is the volume expansion. Instead, linear expansion for aluminum is given. But in the equation, we have to use gamma. So formula is gamma is equal to 3 times alpha. मतलब coefficient of volume expansion is equal to 3 times the coefficient of linear expansion. So in this equation where we have to use the gamma of aluminum, as it is not given directly, we can say 3 times alpha of aluminum into change in temperature. Bas. Now what is left? Start substituting the values. Volume of the container initially 2000. 1 plus 3 times, what is alpha? 24 into 10 power minus 6 into change in temperature is how much? 90 degree. Okay, so we will almost get a value of, okay, almost get a value of 2012. Almost close. Okay, so I'm not actually telling you the value because the calculation takes a bit of time. So I'm telling you approximately it is 2012. So initial volume of water was 2113. The present volume of the container is 2012. So as we all know, as we already have discussed, the amount of water spilled is equal to the new volume of water 2113 minus the new volume of the container 2012. So their change will be volume spilled will be equal to 2113 minus 2012. Almost it will be coming around 100 or 101. Right? Approximately this will be 101. So as 101 is not directly given, we can go for the option B here, 100.44. ठीक है? Sorry, sir, you missed some questions. कहाँ गए थे मिथिलेश? Why 3 times? That is the formula. Okay. So gamma is equal to 3 times alpha. Where did I write? Here I have written. ठीक है? Gamma is equal to 3 times alpha. And at the same time beta. दो सुनो. right? Temperature coefficient of aerial expansion, that is equal to 2 times alpha, beta का value. Crystal clear Myaru? All question कितना है? अरे बहुत सारा questions है श्रद्धा. We'll be having a class almost for 2 hours. ठीक है ना? Okay. So how many of you got this answer correctly? किस किस लोगों को मिल गया था ये सही उत्तर? How many of you got it? And those who got, जल्दी से ये question कर ले. Rajveer, मिल गया था? Very good, very good. So your preparations are going good, I suppose. The revision classes and the revisions and preparations for the upcoming term 2. Right? Well, good, awesome. Uh-oh. So, अरे Meru is already shocked. 2 hours, sir. वो क्या हो रहा है? That's what happens here, right? So, anyone with the answers? I'll tell you. ठीक है? I'll tell you the method of doing this. Mithilesh, Meru, Shraddha, all are going for the option A. I'm not confirming it. Let's see. 50 gram of copper is heated to increase its temperature by 10 degrees Celsius. Okay. So, if the same quantity of heat is given to 10 gram of water, the rise in its temperature is. Look into the first part of the equation. It says 50 gram of copper is heated to increase its temperature by 10 degrees Celsius. Okay, copper's temperature is being increased by 10 degrees Celsius. Don't we have to provide some heat energy for it? Yes. How much? Use the formula. Delta Q given to copper, formula M, right? Then C delta T. Okay, MC delta T. Now M is the mass of copper, 50 grams or 50 into 10 power minus 3. Okay. Now the specific heat of copper is given as 420 and the change in temperature is 10. So this much of heat energy is being given to copper for increasing its temperature by 10 degrees Celsius. In the question it also says that the same amount of heat energy, okay, he is given to water at 10 gram. So if that is the case, how much will be the increase in the temperature of water? So here it is given that delta Q of water, the heat energy given to the water is equal to the heat energy given to copper. And how much is that value? That is 50 into 10 power minus 3 into 420 into 10. This is the value. Now, delta Q of water, matlab the amount of heat energy given to water, how can we write it as a formula? Very simple. Mass of water, specific heat capacity of water, change in temperature of water. Okay, substitute kar le. What is the mass of water? Mass of water 10 grams. That is that is 10 grams. 10 into 10 power minus 3. So specific heat capacity of water 4200. Change in temperature pata nahi, is equal to 50 into 10 power minus 3 into 420 into 10. Common 10 power minus 3, 10 power minus 3. 4200, here also 4200. Right? 0, 0. So delta T is equal to 5. Very simple. मिल गया हमको सही उत्तर. नन्नू मुन्नू. Nannu munnu question, isn't it? Nannu munnu question. सही था, सिंपल था और प्यारा भी था. Right? Any doubt, anyone? किसी को भी नन्नू मुन्नू कोई भी डाउट है? Correct. Very good. Very good, very good. So you look like Vijay. Arey, thank you. Okay. So everyone, I hope you all got it. कोई डाउट है anyone? बच्चा लोग. अरे बच्चा लोग कोई डाउट है? कुछ भी नहीं है ना? Simple dimple. Okay, good. So if the question is simple dimple, I don't think anybody can have a doubt, right? Okay. Go for agla, agla, agla. Time is running. Try to solve it. If you are not able to, I'll be solving it. Okay. Okay. I'll start reading. Everybody listen. Those who are doing, you can continue doing the same problem, okay? And you can keep on giving me the answers here. I'll just read out the answers given till now. Mithilesh is going for the option A here. Meru, A for apple, good. Shada went for B actually. Then who else we have? Okay, A, B is options we have actually. Okay, let's finalize between whether it the option is A or B. देख ले. Body A of mass 2 kg, another body of mass 4 kg. Same material. Okay, if material is same, we have to know that the specific heat capacities of both the material should be same, because specific heat capacities mainly depend upon the material with which anything is being made up of. Okay, so I can write specific heat capacity of the body A is equal to specific heat capacity of the body B. Q? Because both of them are of same material. Okay, they are kept in the sunshine for same interval of time. If the rise in temperature is equal for both, delta T in the body A and delta T, which is the increase in temperature in body B, is the same. Okay, which of the following is correct? Okay, the option is being mainly asked about the heat absorbed by body A and B, and we are asked to compare. Write down the formula for that and we can do the comparison. Delta Q of A. Matlab, the heat energy absorbed by the body A is equal to M. Specific heat capacity SA equal to SB equal to S, let's say, into change in temperature. Okay, delta T. Now at the same time, delta Q, the heat energy absorbed in the body B, is equal to mass of the body. That's 4 actually, right? So I'm going to write as 2 into 2, because 2 into 2 is 4 itself. Now specific heat capacity of the body B is S itself. Change in temperature is also same. 2S delta T, 2S delta T. What can you substitute? Delta QA. Very clear. Delta QB, the heat energy absorbed in the body B, is equal to 2 times the heat energy absorbed in the body A. So heat absorbed by body B is double Q. Why? The only reason is because of its mass. Because the mass of the body B is double. इसीलिए the heat energy in the body B is double. Okay, simple. Simple dimple, single dimple, little star, how I wonder what you are. कोई भी doubts है तो बोल दो, नहीं है तो next question. Next one, right? Everyone ready? Steady? Okay, so Rajveer was giving me the option A. Very good, Rajveer. Okay, awesome with this. Next one. Uh-oh. Nannu Munnu. Let me see. You don't even need time for answering this. Essay. Just like that, you can give me the answers. किसी ने दे दिया क्या? Anyone gave me the answers already? Next one. Yes, Radha. I'm sorry, next question is already there. Okay, Mithilesh, Rukshar. Mithilesh. Okay, so everyone is going for the option A. Okay, so let's go with it. Let's read the question and understand. Which of the following is true about calorimetry? What is being talked about in calorimetry? Let's say when two bodies of different temperatures are made in contact, what will happen? Right, from the body of higher temperature, the heat energy will be flowing to the body of lower temperature. And according to the principle of calorimetry, it says whatever is the heat energy lost by the hot body, it is completely given to the cold body. So it will be equal to the heat energy gained by the cold body. So heat energy lost will be equal to heat energy gained by cold body. So there the energy conservation is actually being talked about. So this calorimetry completely works on the principle of calorimetry. Principle of calorimetry totally based on the conservation of heat energy. ठीक है? Fine. Any doubts? Anyone? कुछ भी नहीं, right? Yes, it's option A. Everyone. Yes, yes, yes. So moving on to the next one. Next. So this is a good question. A good question from the concepts of calorimetry. Just now I have told you what is calorimetry, है ना? It talks about the heat energy that is being moving from one body to another body. Whenever there is a temperature difference, we talked about it. By using the calorimetry, here we have a problem. So go through the problem अच्छे से, नन्हे से, प्यारे से, मुन्ने से, ठीक है, and understand it and start solving. मुझे पता नहीं anybody have given the answers already or not. Sorry, she is missing with my keyboard. Okay. I think sir ने सब question की answer यही रखा है. पता नहीं. Anyway, Mithilesh went for A, Shraddha went for B, Mithilesh, then Meru. Okay. So as such a trend is going on that Ameer Bhaiya has kept all the correct answers as option A. Seems like for this one also everyone is going for the option A. Let's see that trend is true. मतलब whether the option is A or not. Let's get started. देख ले. An engineer drinks her morning tea out of a steel tumbler. The steel tumbler has a mass of 0.3 kilogram. So this is our steel tumbler. Mass of steel is equal to 0.3 kilogram and the temperature of steel is equal to 30 degrees Celsius. Okay. She pours 250 ml of tea. We know 1 liter is equal to 1 kilogram of water, right? So 250 ml will be equal to 250 grams of water, right? So to this tumbler, I am pouring mass of water is equal to 250 grams. Okay, so see she poured that much of water, matlab tea. Here it is said that tea can be considered as water. Okay, so I was talking on that basis. कोई बात नहीं, tea of 250 ml is being poured at a temperature of 80 degrees Celsius. Temperature of water will be equal to 80 degrees Celsius. ठीक है. So after they mix and after these two comes into equilibrium, what is the effective temperature of the entire system? Temperature कैसे? How it is changing? देख ले. Water at a higher temperature is being poured into steel of lower temperature. Tell me what happens. The heat energy will start flowing from where to where? Heat energy will be flowing from the higher temperature body of tea at 80 degrees Celsius to a lower temperature of steel tumbler until both of them achieves a common temperature T. And this common temperature is asked here. Okay, how will we solve? Simply by using the conservation of energy. How many of you do remember conservation of energy concept related to calorimetry? Yes, the heat energy delta Q that is lost by the hot body will be equal to the delta Q heat energy gained by the cold body. We know principle of calorimetry, सबको पता है. Okay. How much of heat energy is being lost by water when it moves from 80 degrees Celsius to a common temperature of T? Formula is mass of water that is equal to 0.25 into specific heat capacity of water 4200 into change in temperature कितना? 80 it was, now it becomes T. So that is 80 minus T is equal to heat energy gained. Who is gaining? The steel tumbler, which was at a lower temperature of 30 degrees Celsius, start gaining heat energy from this T here. So amount of heat energy gained is equal to M. What is the mass of steel tumbler? 0.3 into specific heat of steel 450 into change in temperature. Initially it was at 30, now it becomes T. So this is T minus 30. Change in temperature of what? Kiska change? Of the steel tumbler. Okay, what is the only unknown? I have a chashma, so it will be clearly visible to me. Others also अच्छे से देख ले. What will be the temperature you'll get? Temperature you will be getting after solving as 74.3 degrees Celsius. देख ले, every concept देख ले, every statement देख ले, every lines देख ले, and every calculation that we have done, have a look at it. Very important. Matlab, it's super important. Let's call it in that way. Everyone, waiting for your answers. Sorry, answers you already gave me, right? So tell me, is the concept clear? The method of doing this problem clear? Sabko? Correct answer? Those who got it correct, tell me. Ha sir, it's correct. Meru got it correct. Badhiya. Mithilesh? Formal trader, yours were correct. ठीक है. Sir, A ही है answer. Yes, A is correct. Your analysis is going good, Shraddha. Yay. Sub 80. Let us check. Let me hope. Okay, so at least this time it's not option A. I have told you it's not option A this time. So you are only left with 3 other options to select. Go for it. Anyone? किसी ने दे दिया है क्या? Okay, Shraddha with option C. Mehru with option C. Uh-oh, everyone is going for option C. देख लेगा पड़ेगा. Right? Okay, everyone? देख ले कैसे करेगा? अच्छा वाला क्वेश्चन है, प्यारा वाला क्वेश्चन है. देख ले. Everybody listen. 0.1 meter cube of water at 80 degrees Celsius is mixed with 0.3 meter cube of water at 60 degrees Celsius. We can draw here, right? Here we have water, okay, a kind of water at 80 degrees Celsius, and the volume is 0.1 meter cube. Now we have another quantity of water, and that was at 60 degrees Celsius, okay, and it is having a mass of, okay, initial this was 0.1 and this is 0.3 meter cube. Fine, all good, great. Now what happens? You are mixing this two. Tell me what happens if you mix this two. Water at higher temperature, which is at 80 degrees Celsius, will start losing the heat energy. Delta Q is being lost by this. So as the heat energy is being lost from this high temperature body, what happens? Temperature will be reducing. Same time what happens? This water at lower temperature will gain heat energy. So after gaining, its temperature will start increasing from 60. Upar wala decreases temperature, niche wala increases temperature until both of them achieves a common temperature, which is T. And question is to find out this common temperature. Simple. Whatever we have done in the concepts of calorimetry, whatever was the concepts done in the previous question, same. क्या है? देख ले. Delta Q lost, the amount of heat energy lost will be equal to the amount of heat energy gained by cold body. How much is the energy lost here? देख ले. Formula is M. M is not given, volume is given, right? So mass is equal to density into volume. So M, for that I am substituting volume into density of water into specific heat capacity of water into change in temperature. How much is the change? 80 becomes T. So change कितना हो जाएगा चलो 80 minus T हो गया. So amount of heat energy gained. So mass of that water with volume of 0.3. So mass is equal to volume into density. As both are water, I have put rho itself. Q. Array, if it is water on both the sides which with which the mixture is being made up of, density तो same ही है. ठीक है. Then specific heat capacity of water again same, and change in temperature 60 था, now it becomes T. So T minus 60. Okay, cancel everything, What do you have on left hand side? 80 minus T is equal to, this becomes 3T minus 180. So this becomes 4T is equal to 260. So T equal to 260 divided by 4, which is 65 degrees Celsius. Any doubt? And that's how we get the option C as our correct answer. कोई भी डाउट है तो बोल दे. बोल दो ना जरा. Meru Vishal formal Shruti. Quite smart choice. What was the choice you all made? हो क्या हो गया? विशाल सी, विशाल नो, मान्यता हमारा ऑसिलेशन आगे कब होगा? I'll update you. Shraddha C. Okay. You gave the answer first, Shraddha. Wow, wow, wow. Or are you telling all the answers are given first by you? That's awesome. ठीक है, तो अगला क्वेश्चन के लिए रेडी एवरीवन? Moving on. Next. Go for the next question. It's waiting for you. Simplest question. Those who know the formula of latent heat of vaporization and heat energy absorbed. Bas. Done. Anyone? Shraddha A and B. Arey wah. That's a nice choice of options. I wish you will also be given such kind of options choosing in your exams also. And among the 4, you can pick any of the 2, but still your full marks will be given. Okay, B option, A option. Shraddha goes for B, Shruti is for A, Beena for B, Monty for B, Krishna for A, Formal for A. So I can see a mix of options, but let's see. Right? Come back, everyone, listen. If 2000 joule of energy is required to melt 80 grams of lead kept at its melting point, then what is the latent heat of fusion? Now, what is happening here? The lead is actually getting melted, right? So, for any body, the amount of heat energy required for melting is given by the formula of mass of the body into latent heat of fusion. What is latent heat of fusion? Very simple. That is the heat energy required for melting 1 kilogram of the body. Okay, for 1 kilogram, how much heat energy has to be given? That is latent heat of fusion. So total heat energy that has to be given to a body of mass m is equal to m into latent heat of fusion. Simple, right? Okay. So whatever values are given, just we can substitute it here. Delta Q ka value 2000, right? Yes. Mass is given 80 grams, that is 80 into 10 power minus 3 into latent heat of fusion. So, baki kya hai? So, this will be equal to 2 by 8 into 10 power 5 it will be. 2 by 8, 1 by 4, that is equal to 0.25 into 10 power 5. That will be equal to latent heat of fusion. So we are asked to find latent heat of fusion in multiples of 10 power 5. So the final answer is 0.25 only. Because the question is asked to get the answer in 10 power 5 joules per kilogram. So this is 0.25 into 10 power 5 joules per kilogram. So the numerical before 10 power 5 is 0.25, and that's our answer, which is option D. Doubt? I don't think we can have, or anybody can have a doubt, because it was such a direct question. It is such a nannu munnu question and pyara sa question, right? सर 2 hours क्यों लेनी, क्लास 3 hours ले लो. हाँ 3 hours में मेरा जान भी उठ जाएगा ऊपर. But anyway, we can try to do some 3-hour sessions and all, है ना? No doubts, right? So अगला question पे जाएगा. This is one of the big question. मतलब बड़ा question होता है ना, इतना बड़ा, इतना लंबा question, right? Yes. So this is that kind of a question which includes all the concepts of latent heat of fusion, latent heat of vaporization, specific heat capacities. All these concepts will be super clear once you all do this problem. ये problem किया है तो पूरा का पूरा हट जाएगा. Any doubts if at all you have? So everyone try doing it. What I'll do is use some nannu mundu time. ठीक है, give me nannu mundu time to solve it. In the meantime, I'll just wash my face and I'm back. What about you all? Anyone with the answers? Bachcha log, have you all given me the answers? Okay, I didn't go. आप सब लोग कहाँ जा रहे हैं? Where are you all people going? अरे question करके जाओ. Okay, Mithilesh. Fine, fine, fine. Shraddha, Lakshman, option C and option D बोल रहा है. Who all are giving option D here? Lakshman is going for option D, Shraddha for C, Maru for B. ठीक है, ठीक है. So I'll try solving it for you. Everybody listen. Okay. So the method of doing this problem is very crucial. I want every one of you to listen to me here. Okay. Calculate the heat required to convert 3 kilogram of ice at minus 12 degrees Celsius to steam at 100 degrees Celsius. Now specific heat capacity of ice, specific heat capacity of water, latent heat of fusion of ice, latent heat of steam, sub दे दिया है. We need to find out the total heat energy given. This can only be achieved by drawing a diagram, else it will be pura ka pura or complete confusion it is going to be. So what we're going to do, I'm just going to draw I'm going to make a perfect diagram of the question that is given here, so you can have a better understanding of whatever it is. Okay, fine. Let's start doing it. Here it goes. Now, as you can see here, we have ice at minus 12 degrees Celsius. Okay, and the mass is equal to 3 kilogram, isn't it? Yes, yes or no? Yes, it's confirmed. I was looking where that 3 is there. Okay, now this ice, I have to keep on providing heat energy so that I can convert this ice at 0 degrees Celsius. Ice at minus 12, I'm converting the ice to 0 degrees Celsius by giving some heat energy. So I'm marking the heat energy as delta Q1. How much heat energy has to be given? Formula is mH delta T. How much is mass? That is equal to 3. What is specific heat capacity of ice? 3.35 into 10 power 5. 3.35 into 10 power 5 into change in temperature. How much is change? From minus 12, it becomes 0. So the change is 12 degrees Celsius. Question is to find out the total heat energy for converting ice to steam at steam at 100 degrees Celsius. But now, as a first step, we have converted ice at minus 12 degrees Celsius. Ice at minus 12 degrees Celsius, we have converted ice at 0 degrees Celsius. Delta Q1 was this, right? After this, what we're going to do? Now, I have to convert this ice at 0 degrees Celsius to water at 0 degrees Celsius. Don't we have to provide some heat for converting ice to water? Yes. So, delta Q2 is the amount of heat energy, let's say. Formula is M into latent heat of fusion, right? What is the mass? It's always 3. And latent heat of fusion of ice, 2001. So this much of heat energy has to be given for converting ice at 0 to water at 0. Okay, done. Next part is converting water at 0 degrees Celsius to water at 100 degrees Celsius. देख ले मेरे बच्चा लोग, water at 0 we have converted to water at 100 degrees Celsius. Don't we have to provide some heat energy for it? Let me mark it as delta Q3. And how will we get to know the exact value of heat energy required? Formula Ms delta T. How much mass? 3. Specific heat capacity of water 4186. Change in temperature from 0 it becomes 100. So change is 100. Is it done? Was our task to find out the heat energy for converting till water to 100 degrees Celsius? No. This water at 100 we have to convert to water vapor at 100 degrees Celsius. A change of state has to happen. So for this, don't we have to provide some heat energy? Yes. I'm marking it as delta Q4. And how can we calculate the exact value? Formula is there. Mass into latent heat of vaporization. Mass is 3. Latent heat of vaporization of steam 2. I'm writing it here, 2.256 into 10 power 6. So the ice at minus 12 degrees Celsius, by giving these much of heat energy, we have converted to vapor at 100 degrees Celsius. Question is to find out the total heat energy for it, delta Q total. So for that, add the heat energy delta Q1 plus delta Q2, delta Q3 plus delta Q4. Add all these values. Okay, add all these heat energy that we totally provide so that we can get the final heat energy given. Value will be 9.1 into 10 power 6. So add all these value, ये और ये. Okay, मिल गया? Doubts? कुछ भी? None? Thoda fast. Uh-oh. I thought everybody needs a slow explanation so that everyone can understand the entire concept behind this. Okay. ठीक है? Fine. Correct? Okay. Let's move for the next one. Again. So, what do you think about the session till now? Are you able to improve your concepts related to all these topics? It should be happening, right? Let me see. Anybody already gave me the answer or what? Anyone? Okay, so you can keep on solving the question, मेरा बच्चा लोग. What I will do is I'll start explaining the question first. Okay, then I'll start explaining the solution. You can keep on giving me the answers, no worries. Okay, when 0.15 kilogram of ice at 0 degrees Celsius is mixed with 0.3 kilogram of water at 50 degrees Celsius in a container, the resulting temperature is 6.7. Okay, calculate the heat of fusion of ice. Latent heat of fusion of ice, na? We are asked to find that out. Informations are given. Let's picturize the same and understand this in a better fashion. What we have? We have water at 50 degrees Celsius and the mass of water is 0.3 kilograms. Okay. Then we have ice at 0 degrees Celsius and the mass of ice is 0.15 kilogram. Okay, you're mixing this two. Tell me what happens. Water which is at a higher temperature will lose heat energy and ice which is at a lower temperature will start gaining heat energy. Matlab, mixture, when it comes to equilibrium, they are having a temperature of how much? Temperature of the mixture is found to be 6.7 degrees Celsius. If this is the case, find out the value of latent heat of fusion of ice. Question. Same concept we can use. Whatever is the heat energy lost by water, delta Q lost because its temperature is being decreased here is equivalent to the heat energy gained by ice. Now, when heat energy is being gained by ice, two process happens. What are? First, ice at 0 degrees Celsius will be converted as water at 0 degrees Celsius. Then there will be an increase of temperature of water from 0 degrees Celsius to 6.7. So whenever ice is gaining heat energy, two process happens. First, ice converts itself into water at 0, then this water will be gaining to a temperature from 0 to 6.7. Fine. So for this total process, some amount of heat energy is being gained. So by using the concept, which concept? अरे हमारा calorimetry concept, heat energy lost, we'll write here, right? Delta Q lost will be equal to delta Q gained. Who is losing? It is water at 50 degrees Celsius and the amount lost is equal to mass of water, that is 0.3, into specific heat capacity of water is given as 4186 into change in temperature. देख ले 50 it was, now it became 6.7, so change is 50 minus 6.7 is equal to the amount of heat energy gained. कितना gain किया? कितना gain किया? देख ले, initially ice at 0 becomes water at 0, so the heat energy gained is equal to mass of ice into latent heat of fusion of ice plus, now it became water after providing this much of heat energy. ठीक है, उसके बाद water at 0 degrees Celsius will increase its temperature to a temperature of 6.7. So formula for that is mass of water, specific heat capacity of water into change in water. Start substituting. Mass of ice is 0.15 into latent heat of fusion plus this mass of water. Matlab once ice convert itself into water, Mass remains the same, which is 0.15 itself. Specific heat capacity of water 4186. Change in temperature is 6.7 minus 0. Q, water at 0, it became 6.7. So the total heat energy used for these two purposes will give you the amount of heat energy gained. What is the only unknown here? LF. So once you solve for this LF, कितना मिल जाएगा? 3.34 into 10 power 5. सही आसान ही से मिल जाएगा. देख ले एक बार. Everyone have a look at it. कोई भी डाउट्स है तो पूछ ले. Good afternoon, Arpan. Any doubts? बच्चा लोग कोई भी नन्नू मुन्नू डाउट्स है क्या? छोटा मोटा डाउट्स है क्या? No? Yes, yes, no? So I hope you all have copied down the question and the next question. अरे कौन पूछता है सर ऐसा क्वेश्चन? तो इतना सिंपल क्वेश्चन कौन पूछता है सर? हम पूछता हूँ. तो पूछ लिया तो आंसर दे दे. पूछ गया तो आंसर्स. अरे outdoors in winter, why does a piece of metal feels colder than piece of wood? क्यों? Because the metal is having a larger conduction than our wood. इसीलिए. ठीक है. नन्नू मुन्नू, लक्ष्मण, श्रद्धा, रुक्षार, very good. It was a नन्नू मुन्नू question. ठीक है. Okay. Next one. This is beautiful question. कोई भी डाउट नहीं है ना अन्वेश का? All good, all awesome. So अगला क्वेश्चन कर ले. Everyone with full of your energy, by giving your full of attention, do this problem and give me the answer as soon as possible right now. Yeah, I'll read the question. Still, you can keep on solving it there, okay? And keep on giving me the answers in the chat box. The end of two rods of different materials with their thermal conductivities, area of cross section and length are in the ratio of 1:2. मतलब we have two different rods. Okay. So though the rods are different, K1 by K2 value, मतलब the ratio of their thermal conductivities, area of cross section, that is A1 by A2, and length L1 by L2. All these are having the same ratio of 1:2. Okay, and they are maintained at the same temperature of delta T1 is equal to delta T of 2. मतलब the temperature difference across both the rods that we have chosen is the same here. Okay, if the rate of flow of heat in the first rod is 4 calories, then the second rod में कितना है? What is given? dq divided by dt in the first rod is 4 calories per second. Question is, what is dq by dt? मतलब the rate at which heat transfers in the second rod? Question mark. कैसे करूं? कैसे कर सकता है? We just need to know the formula for dq by dt when heat energy is conducted through a rod. What is it? dq by dt is given by Ka, change in temperature divided by length. So as both of them are having the same temperature, right, dq by dt is directly proportional to Ka divided by L, because temperature is C. So obviously this is a constant for both of them, so it depends upon Ka by L. So the question is, dq by dt in the first case to dq by dt in the second case will be equal to. कितना? As it is directly proportional to K, so that will be equal to K1 by K2. As it is directly proportional to A, that will be A1 by A2. And as it is inversely proportional to L, that is L2 by L. देख ले, we already have written what? K1 by K2, A1 by A2 is 1 by 2, right? So K1 by K2 is 1 by 2, A1 by A2 is 1 by 2, and L2 by L1, L1 by L2 is 1 by 2, so L2 by L1 ulta 2 by 1, 2 cancel, this is 1 by 2. Okay, now देख ले, dq1 by dt उसका वैल्यू 4 दे दिया है, ठीक है, dq by dt of 2, this is unknown. So how will you find out? dq by dt of 2 is equal to cross multiply, 4 2s are 8. हो गया. यूनिट क्या है? Calories per second. And that's our answer. Doubts any? No, right? Simple. Yes, it is. So, but you should be having a practice of doing all these kind of problems. So, whenever you come across these kind of questions, you'll be doing it in seconds less like this, right? Sub clear, everything super awesome, super great, with a beautiful smile. Yes? Okay, so go for it. Hi Samarth, Shraddha. So, can we proceed further? If nobody is having any more doubts, कुछ भी नहीं है तो we can proceed further. Sir, I am visible to you. How can you be visible to me, Miara? Your chat is visible there in the chat box, obviously. Okay, so we can proceed further, है ना? बच्चा लोग बोल दे. कर सकता है अगला क्वेश्चन को. Shall we jump? Okay, मैं jump किया. This is our next one. Read it, try to understand, and try to give the answer within some seconds, just like that. Let me see. Answer. Aradhya scored 32 out of 35. Okay, Aradhya, that's a great thing. I'm so happy to hear that. Okay, अच्छा कर दिया आराध्या. Okay, बहुत अच्छा. मैं तो बिल्कुल खुश हो गया आपका ये सुनकर. Okay, and keep on moving. And you know the 3 more marks difference is there. You can easily make it for your term 2 or when you go to your plus 2 levels. No worries. You are the best. So answers for this everyone is giving for option B, है ना? Shraddha, Rukshar, Samarth, Kashish, ठीक है. Hi Ronit, Rohit, है ना? ठीक है. Chetan B, Samarth B. So everyone is going with the option B here. Let's see कैसे करेगा ये. Okay. Two ends of rods of length L and radius r of the same material are kept at the same temperature. Which of the following rods conduct maximum heat? We have 4 different rods, okay, and the value of length and radius of all those 4 different rods are given as 4 different options, but all those 4 rods are made of same material. मतलब thermal conductivity है ना, K is same for all the rods and they are kept at the same temperature difference. Delta T भी same है for all the 4. If that's the case, okay, which one can conduct maximum amount of heat energy? What is the formula? Tell me. The amount of heat energy that can be conducted through a material is K A change in temperature divided by L, right? Material same है for all the 4. So K same, change in temperature is same here. So dq by dt is directly proportional to area of the ends of a road which has circular basis pi r square by L. We can say dq by dt is directly proportional to r square by L. So among the four options, whichever is having the greater value of r square by L, that will be the one which conducts maximum amount of heat energy dq by dt. So there is no other way. You just have to keep on going and finding out r square by L value for all the four options. First options way, as it is comparison, we are not going for conversion from meter to centimeters and all, right? R square, R is 1. So 1 square by L is 50. 1 by 50 is option A. For option B, R square by L value, R square is 2. That is 4 divided by L is 100. C, R square, that is 0.5. The whole square divided by L is 25. And option D, R square 1.5. The whole square by 75. After you compare, you will easily get that it is the option 4. Sorry, option 4 by 100, which is option B. It is the correct answer. Because this will be the one which has the maximum value. The one which has r square by L value largest will be having dq by dt largest, which means more heat transfer. Mil gaya? It's option B the correct. How many else has given? Okay, Lakshman has given there. Samarth has given there. Okay, cool, awesome. So moving on to the next one. और चलो कुछ भी doubt है तो बोल दे. Yes, Shraddha, you're the first person to give. बढ़िया बात है. Lakshman, yes. Okay, sir. Okay, fine. So moving on to the next one then. This is an NCERT problem and it's a very good problem, so don't miss it. आ गया समझ? बढ़िया बात है. So do this. Anyone? It's a very good question actually. From the topic of conduction. Anybody gave? You didn't get this, Govind? I'll explain. No worries. Okay. So chill ho ja. I'll start reading the question. Okay. So everyone is taking time to answer. So it's fine. I'll read. It goes like this. What is the temperature of the steel copper junction? Can you see steel here? I know the picture is not so clear, but still you can see it. Steel here and copper here, right? So this is the junction between them. So what is the temperature at this junction is the question. Okay. Length of the steel rod is 15. Length of the copper rod is 10 centimeters. Temperature of this side of the steel is 300. Temperature of the other end is 0 degrees Celsius. Area of cross section of steel is 2 times that of copper. Matlab if copper is having an area of A, steel will be having an area of 2 times A. Okay. Thermal conductivity of steel and copper is given. Okay. How to do this? We know that this steel and copper is acting as a bridge so that heat energy can move from this high temperature furnace to this low temperature ice box, right? So there is only one way for the heat energy to flow from furnace. Kaise? In this direction, ऐसे, right? It will go like this, it will go like this, it will go like this. You know that heat energy cannot be accumulated anywhere, okay? And we are talking about ideal case where heat energy is not being lost. So as you can see, whatever is the heat energy flow happening through steel, the same will be the heat energy flow that is happening through copper. Just like two resistors are connected in series. If I is the current passing through one of the resistor, right? Through the second resistor also same current travels. So here also the heat energy flowing through steel, dq by dt, heat energy passing through steel is equal to dq by dt passing through what? Copper. Simple. Start writing down the formula for that for easy comparison. So dq by dt of steel is equal to Ka dt by L across steel will be equal to Ka dt by L across copper. Start substituting. K of steel, how much? 50.2. Now area of steel is 2 times A. Change in temperature across steel, देख ले. This is 300, this end is T, so change is equal to 300 minus T, the whole divided by how much is the length of steel? That is 15, is equal to K of copper. How much is it? K of copper 385, right? Area of copper, let's put it as A itself. Change in temperature of copper, देख ले. This end of copper is T, other end is 0. So T minus 0 by length of copper. How much? That is 10. We are not converting from centimeters to meter because we are just doing the comparison equation. So whatever conversion we make and we make here, it will automatically get cancelled. इसीलिए नहीं कर रहा है. ठीक है? So we have this set of formulas to solve. The only unknown क्या है? T. I know that you guys are super fast in solving mathematics, isn't it? So once you solve, we will get the option C, which is 44.4 degrees Celsius. Yes, D is correct, Shraddha. Not D is correct, C is correct. 44.4. Okay. Okay, so option C will be a correct answer. Lakshman, मिल गया सबको? मिल गया तो मिल गया, आंसर तो मिल गया, मजा भी आ गया, isn't it? ना 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 ना. डाउट है तो बोल दे. बोल दो ना जरा बच्चा लोग. अरे don't sleep from there, be active. We have 2-3 more questions, right? With full of energy, we can solve those questions also. ठीक है? Everyone, bring back your energy. Okay. So moving on to the next one. This is again another good question, let's say. अच्छा वाला, प्यारा वाला, नन्ना वाला, मुन्ना वाला question है. Anyone? Answers. So please sing a song. बोल दो ना जरा दिल में जो है छिपा, मैं किसी से कहूँगा नहीं. A is correct. Meru B, Lakshman B. Okay, everyone is going for options B. Let's check. 3 rods we have. Material same है. Okay. Cross section same है. Okay. And length भी same है. देख ले, 3 rods we have. Length same, area same, thermal conductivity same. This end of the rod is at 0. The other end of the rods are at 90 degrees Celsius, as you all can see. Temperature of the junction of the rod. मतलब here है ना, कितना temperature. So first we look into that simple concept on basis by which we can do this problem. कैसे? इधर तो छोटू temperature, इधर तो बड़ा temperature है. क्या हो जाएगा? From higher temperature, the heat energy will start flowing. Let me see. Let me say the heat energy flowing is I1 from 90 towards the junction. Just like that, from this 90 degree Celsius also, another heat energy will be flowing. Let me call it as I2. So I1 and I2 from this high temperature will be flowing to the junction. After reaching at the junction, what happens? These two will join together and will be moving towards the 0 degree Celsius, right? Yes or no? Yes. So tell me, what is the relationship between I1, I2 and I3? Relationship क्या है मेरे बच्चों? क्या है? I3 will be equal to I1 plus I2. Why? Because whatever heat energy comes into the junction, which is equal to I1 plus I2, will be equal to the heat energy leaving the junction, because heat energy cannot accumulate everywhere, or total heat energy is always conserved, right? Heat energy comes, heat energy leaves. So coming heat energy I1 plus I2 is equal to I3. How will we expand this? Tell me formula for heat energy flowing through a road का formula कितना है? K A change in temperature. What is change? Here तो 90 है, इधर तो T है, so change is equal to 90 minus T the whole divided by L. Why am I not writing K1, A1 and L1? It's given temperature, same material है, मतलब thermal conductivity is same, area तो same and length is also same, given, right? Plus heat energy flowing through the second rod. Ka delta temperature is 90 minus T whole divided by L. Same. So plus same value. So instead doing that, I am writing it as 2 because I1 and I2 का value same ही हो जाएगा. Equal to I3. Value Ka, the heat energy flowing through this. Change in temperature कितना? Here T, here 0. So that is T minus 0 divided by L. बस Ka by L cancel हो गया. Here what remains? T. Here 2 90s are 180 minus 2T. Minus 2T comes to the left hand side, 3T 180 and T का value कितना है? 180 by 3, that is equal to 6. हो गया तो हो गया, आंसर तो मिल गया, मजा भी आ गया, है ना? हाँ सर, बिल्कुल बिल्कुल मजा आ गया सर, अच्छे से आ गया सर. Hi Anna, I am from Andhra. I really love your teaching method. Thank you. Aditya Singer साहब, मैं तो खा लिया. अरे गिटार तो इसी रूम पे नहीं है, दूसरा रूम पे, तो बहुत परेशान है क्योंकि आई जस्ट हैव टू टेक अप दिस माइक फ्रॉम हियर, नीचे रखना है, दूसरा रूम पर जाना है, फिर वापस आना है, फिर भी ये रखना है. अरे बाप रे, बहुत सारा काम. So instead we can save all these work and what we can do? Yes, we can do the song session tomorrow's class पे. You all will be coming, right? प्यारा बच्चा लोग सब आएगा ना, पूरा का पूरा entire army will be coming. So what's the issue? So tomorrow we can do. So have a look at this particular question. कोई भी doubt है तो बोल दे, किसी तरह का भी, any kind of doubt, let it be. You can ask me, or else it's time to move to the next one. And here it is. So actually we were talking about the conduction topic or doing questions from conduction. Now we have jumped to the topic of radiation. Anyone? You can try reading the question and doing it in your own way. Okay. You can give the answers here in the chat box. I'll be looking at it. Who all are my super awesome bacha logs? Okay, everyone is going for option C there, right? Which is 0.84. Anyway, I'll start explaining. A block body of surface area 10 centimeters square is heated to 127 degrees Celsius. Matlab, the black body is having a temperature 127. Is suspended in a room of temperature 27 degrees Celsius, cool. Calculate the initial rate of loss of heat from the body to the room. Okay, how much of heat energy is being radiated, or how much of heat energy is moving out of the body in terms of radiation is a question. We just need to write down the formula. dq by dt is equal to EA sigma T raised to 4 minus T surrounding raised to 4. E is emissivity. Emissivity of a black body is 1 into area of a black body is 10 centimeters square. So multiply it with 10 power minus 4. Sigma 5.67 into 10 power minus 8. Stefan's Boltzmann constant. ठीक है. T raised to 4. Temperature of the body. Is it 127? नहीं. बिल्कुल भी नहीं, because temperature of the body is 127 plus 273 and has to be written in Kelvin scale. How much? 400. So this is 400 the whole raised to 4 minus 27 degrees Celsius, the temperature of the surrounding. You have to write it in Kelvin scale. Adding it 27 plus 273, that will be the temperature of surrounding, that will be 300. If you do the math, कितना मिल जाएगा? Watts. Don't think how this unit watt came. देख ले, dq by dt is what we are finding. Heat energy per unit time. Energy by time is power, so watts. So the unit is 0.99 watts here. No confusions, I suppose. Nannu Munnu. Anybody who all gave me the answer? Update me. Who all gave me the answer? Lakshman gave me the answer there. Option A. Anyone else? किसी ने और दे दिया क्या? और किसी ने दे दिया हमारा उत्तर? और किसी ने दे दिया? कोई भी नहीं दे दिया? कोई भी नहीं दे दिया? Hi Sudeep. Where were you? In the class? Wrong. कोई बात नहीं, कोई बात नहीं. Happens, right? Okay. Sorry, late. No worries, no worries, no worries. Okay. तो पता है क्या? What we are gonna do? So we have a bonus question. मतलब one last question before we end the session, and this is what we are gonna do now. देख ले. Everyone, here we go. What is the emissive power of the sun when its temperature is doubled? Emissive power matlab heat energy released per unit time, dq by dt. What happens to dq by dt when the temperature of the body is doubled? Nannu Munnu. Anyone can give me the answer. किसी को भी दे सकता है. किसी रोज तुमसे मुलाकात होगी, मेरी जान उस दिन. See 8 times. Okay, I'll write down. Now, when initially sun was having a temperature of T itself, okay, without considering the surrounding temperature, because we all know that the temperature of the sun is very high compared to the temperature of the surrounding. So temperature of surrounding we can actually neglect. Okay, so in that case, emissive power, which is dq by dt, will be equal to, formula is sigma A T raised to 4. Okay, now let's see what will be the value of emissive power, dq by dt, when the temperature is doubled. So dq by dt dash is equal to sigma A, temperature is 2T, the whole raised to 4. 2 raised to 4, 2 2s are 4, 2s are 6, 8 2s are 16. 16 times sigma A T raised to 4. Have you all seen this, मेरा बच्चा लोग? Sigma A T raised to 4. Sigma A T raised to 4. हाँ सर, देख लिया है. वो है dq by dt. This is 16 times. So dq by dt, the whole dash is equal to 16 times dq by dt. हो गई बात, आ गया समझ हो गई बात. Okay, and that was the last question for today's session. So जल्दी से फटाफट बता दे कैसे था सेशन. How was the session मेरे बच्चों लोग? Krishna, yes, very good. D. Rahul, Ardad, D. Lakshman, D. The formal trader, D. Okay, many are giving me the options D now. Very good. सेशन कैसे था मेरे बच्चों लोग? अच्छा था? अच्छा हो तो those who haven't shown some love towards your bhaiya, this is your time. Move your cursor and click on the like button बच्चा लोग. ठीक है? Okay, how did it go Sudeep? I'm so eager to know. कैसे था? Physics paper कैसे था? Too awesome Siddhi. Good. Rahul, yes. Amazing. Okay, good to know that बच्चा लोग. Good to know that. Okay, so that was the last question of today's class. And super duper amazing Meru. Amazing trader Krishna. KGF, unbelievable. Okay. Fine. So thank you so much for all those beautiful comments out there. Now you can join me. Okay. Matlab, you can join all the educators of Unacademy by being a part of Unacademy family, by making iconic and plus subscription. Offer is going on because exams are coming, right? So for the first 500 subscribers, if you make 3-month subscription, extra 1 month is given free. And at the same time, if you use my code, which is AMB10, you will be given extra 10% of discount. So don't miss it. Now, Prodigy exam is extended. Next exam is going to happen on Feb 27th. So everyone, you can come and join because in this Prodigy exam, you can get a lot much of scholarship for your upcoming colleges, right? You can enroll it for free by using the code of AMB10. Okay, the batches for class 11, as you can see, you can come and join that for 12th. Then special class timetable, I'll be soon updating you. Okay, fine. These are the awesome features of special classes, live class, question tabs, quizzes, leaderboards, everything is awesome. Fine. Okay. Now, thank you so much everyone. As I have said already, those who haven't liked the session, you all can like it. That's a simple way of showing some love and telling that we want more and more sessions like this. Okay? Share the session to all your friends. Okay? Subscribe to the channel. So, bachalo, thank you so much. Dhanyawad for being here, making the class so active, giving answers to all the questions. You guys are the best. So, फिर मिलेंगे चलते चलते. Bye bye everyone and take care.